We are live. Okay, good. I need to mute YouTube. All right, so hopefully everybody can hear me. And I see some heads nodding, so thank you. Thank you so much for being here. We're going to be talking about visualization literacy, and we will start with a paper, and then we will continue with the panel. We have both ready, and I will be chairing the session. I will also be moderating the panel. My name is Mario Romero, and I'm an associate professor at KTH. The paper that we'll start discussing is a true map literacy, a classroom-based investigation. So as soon as you're ready, you can cue the video. Thank you.
Hello everybody, I'm Elif Fırat from University of Nottingham. I'm going to be presenting our paper, Tree Map Literacy, a classroom-based investigation. This is a kind of view of what I'm going to talk about today. First, I'm going to give you an introduction to the topic and some related works. Also, I'm going to talk about challenges of interpreting tree maps and tree map literacy assessment. Then I'm going to introduce our tree map literacy test and pedagogical tree map tool. I'm going to talk about classroom evaluation and the results of the quantitative and qualitative analysis. Finally, I'm going to talk about some limitations and future work. I would like to start with the question of what is visualization literacy? A simple definition is the ability to interpret and understand visual designs. Visualization literacy has gained recognition in the educational and information visualization communities because visualizations are becoming a fundamental part of the education. However, enhancing the educational process with graphical representations and promoting visualization literacy are important goals. We wanted to study tree map visualization. It is an efficient way to represent hierarchical data and requires a special layout algorithm. But displaying the large hierarchical datasets increases the complexity of the tree map, causing difficulty in tree map comprehension. Contributions. We aim to identify barriers to enable a complete literacy of tree maps. We investigated the barriers to tree map understanding and literacy. We developed a tree map literacy test. Also, we designed a novel pedagogical application. This application facilitates both teaching and learning of tree maps and advances tree map visualization literacy. Related works. There are several works focused on improving visualization literacy. I will mention some of them as an example. Boy et al. Developed a method to identify users' visualization literacy level. Alper et al. Introduced an online platform to improve visualization literacy for early education. Another work by Kwon and Lee focused on teaching parallel coordinates, while Fuchs et al. Introducing a tool to use for both learning and teaching clustering algorithms using scatter plots. The last one is Lee et al. Presented visualization literacy test containing the most frequently used visual designs. The challenges of interpreting tree maps. We identify and study the challenges that prevent users from interpreting and comprehending tree maps correctly. We came up with 5 barriers to this successful tree map interpretation. The first one is hierarchy. One of the barriers to the tree map literacy is based on the fact that the tree map conveys hierarchical data. The tree map displays the relationship between hierarchically structured data attributes. The second one is layout. It aims to increase the visibility of small items in a single image. However, the complexity of the layout algorithm can make it difficult to visually explore the data and comprehend the tree map. Size. The larger data set size is more difficult to understand because more rectangles cause higher visual complexity. Labels. Absence of node labels or limited display of the labels in screen space can cause difficulty in understanding the tree map. Legend. A color legend can be used to represent value ranges visually. The absence of a color scale can lead to barrier in tree map interpretation. In this image, shows most frequently used visualizations in VLAN paper. It's evident from this figure that the tree map design features several characteristics that distinguish it from the other most popular visual designs. First of all, tree maps are not based on a simple Cartesian coordinate systems and features labeled and numbered axes like the other visual layouts. Tree maps use a layout algorithm to guide the placement of rectangles. Also, tree map is the only design that presents hierarchical data and can be used to display most individual data samples. Because of presented differences, tree map can be viewed as more complex to understand than the other designs. Tree map literacy in the classroom. We explore how effective students were at creating a tree map by looking at the historical results of the information visualization assignment in 2018 and 2019. We gave out homework assignments to the students for our data visualization module. They were required to create 5 different visualizations for a given data set. We searched to find evidence of the students' strengths and weaknesses in generating the tree maps, as well as their level of comprehension and interpretation. We drive criteria, shown on the left side of this image, enable the assessment of tree map literacy. The criteria consist of questions examining which tree map features are understood by the students, such as the data hierarchy, internal node, leaf nodes, labels and legends, and color mapping. We can see that on the histogram in 2018, 68 students out of 85 submitted a tree map design, and 58 of them stated correctly what color was mapped to in their design. However, only 33 students could describe what the internal node size was mapped to. In this one, in 2019, we asked students to create a tree map image for a given data set in addition to creating 5 different visualizations. Similar to 2018 results, students answered questions about the data hierarchy, leaf nodes, and color-related questions correctly more than questions on internal nodes. Only 26 students could describe internal node size correctly. Also, they were not very successful in providing unique observations and the correct name of the tree map layout. This investigation on tree map literacy provides insight into students' tree map literacy skills and enhances our knowledge of what they struggle with the most during the tree map construction. This evidence illuminates identifying the barriers to the tree map literacy and guides the development process of our tree map educational application. We developed a tree map visualization literacy test to measure a user's tree map literacy skills and identify the barriers to the tree map comprehension. I'm going to show you the video to introduce our tree map literacy test. We developed a tree map visualization literacy test to measure a user's tree map literacy skills and identify the barriers to the comprehension of a tree map. We search for tree map examples to establish a test with diverse tree map designs for users with varying level of tree map literacy. Answering tree map literacy test questions required the evaluation of multiple factors on the tree map simultaneously. Therefore, questions were classified to identify how users perform in interpreting the tree map features. Each example is accompanied by a brief explanation of the tree map image, and multiple choice questions. We designed a novel pedagogical application. This application facilitates both teaching and learning of tree maps and advances tree map visualization literacy. I'm going to show you the video of the software. The tree map application aims to facilitate understanding of a hierarchical data structure and support correct observation by displaying the data correspondence between a traditional tree structure and a tree map layout simultaneously. On this software, we display a historic health dataset called Project Tycho, provided by Pittsburgh University. On this tree view, the US is divided into 5 regions to build the hierarchy. When the rectangle is highlighted via mouse over on the tree view and the corresponding rectangle on tree map is highlighted. The internal node can be expanded by subdividing the region to individual states in the region. This gives a feel the layout process of the tree map. Also, states are subdivided to different years. The number of people diagnosed with the disease is shown on the tooltip. We can navigate to see the different corresponding and move around the different levels of the hierarchy. Moreover, we can display another disease and change the color scale. Colors represent the number of people with disease, mapped to years, states, and regions. We designed a classroom-based user study to evaluate the participants' tree map literacy and the effectiveness of our pedagogical tree map software. We provided our tree map visualization literacy tests as pre and post tests. Some 25 students participated in the study. We described the procedure of our study and provided all participants with the pre-test tree map questionnaire. After the completion of the pre-test, we randomly sampled half of the participants to be allocated to the software group and a slides group. The participants in the software group were provided with a tree map software demonstration and given time to interact with the educational tree map tool. The slides group was shown only traditional tree map slides used for teaching tree map concepts. After completion of the 2 individual sessions, all participants were given the post-test questionnaire. Both pre- and post-test sessions were 20 minutes long. Before completing the user study, participants answered 12 interview questions referring to their background, to test questions, and the tree map software. According to our quantitative analysis of test data, the pre-test results didn't differ significantly between 2 groups of the students. Students attended the slide session answered correctly on average 62% of the pre-test questions, and the students in the software group answered 72% of these questions correctly. However, the results of the post-test were significantly different between 2 groups. Students attended the slide session answered correctly on the average 79% of the post-test questions, while the students who interact with the software performed much better. They answered correctly 89% of the questions. Overall, there was no significant difference between these 2 groups of the participants with regards to the improvement of their tree map literacy level. Both groups have seen on average 17% improvement in their results from pre-test to post-test. However, participants in both groups answered the post-test intervention test questions faster than the pre-test questions. We classify questions based on the tree map features, such as hierarchy, leaf nodes, color, label, and layout algorithm, to test where they struggle at most to comprehend tree maps. I will show the question classification on the table in the next slide. Results don't show any significant difference between the 2 groups taking the pre-test for any of these 5 categories. But for post-test, participants in the software group perform much better in the questions related to the color, leaf nodes, and layout algorithms, while there was no difference in the questions testing hierarchy and labels for both groups. We conducted a thematic analysis using the feedback gathered from the interview about the literacy test and the tree map tool. We identified 5 themes for the literacy test: hierarchy, labels, colors, layout, and the size, that shows strong links with our hypothesis. One of the participants said for the tree map images provided in the literacy tests, the more data being represented translated into more dense tree maps, which made certain things hard to spot. That refers to layout algorithm. The tree map contains many boxes that are hard to see. That refers to data size. Another student said it wasn't clear how to compare the nodes and sometimes too many colors. That refers color. From the feedback on the tree map tool, two themes were identified: hierarchy and instruction in active learning. A participant said about the software, it breaks the tree down so you can only view what you want to see, and I can see the relationship and the categories of different data. That refers the hierarchy shown on the tree map tool. Another participant said the visual feedback when hovering and the pop-up were helpful, and hands-on approach was effective. That shows the interaction and active learning. The table indicates questions rank from the most difficult to the easiest based on the number of correctly answered questions. Also, I mentioned earlier, it shows classification of every question based on the tree map aspects that are necessary to comprehend for answering the questions correctly. Contrary to our initial belief, questions might focus on one aspect. Actually, questions require a user to understand 3 or 4 tree map features simultaneously. Some participants with data visualization background and availability bias might have played a role in shaping our findings, as the participants' recruitment happened over the summer period. Future work: improving the literacy test with a wider variety of data and tree map visualization design can be a good future research. More studies to reinforce the educational tool can be conducted with a diverse group, including more participants can be another future work. As a further research with participants from non-computer science fields for investigating the influence of users' familiarity with tree maps would be very interesting. For the educational tree map tool, providing labels for each rectangle directly on the software and enabling to view large data set with a different layout algorithm would be a good future work. Thank you so much for your attention.
I saw that you added some applause.
Yes.
That was great. That was great because I was just about to applaud you. Thank you. Thank you for doing that for us.
Thank you. Thank you very much.
All right, great. So we have questions on the YouTube channel, and I will start with Johanna Smith's question, and probably pronounced Schmidt. Do you think there is a bias in the data if only computer science students participate in the study?
Actually, this is possible because computer science students are more familiar with the concept of tree map. But this is our future work to participate, to include broader backgrounds from different departments or from different people, I can say.
I have a follow-up question to that.
Yeah.
You were using these tools to evaluate people's literacy. Were you also using the tools to evaluate or assess their learning in class? Did it have a connection to their grades?
No, actually, first of all, we tested this in a classroom environment. So we basically gave the software to the student to enable them to interact with the software, have an active learning experience. However, we couldn't test their results, whether the effects on their assignments or test results.
Is this something you would do in the future?
Definitely. Yeah.
Exactly. Give them the task of learning how to read information out of tree maps and then assessing it with the tool that you have created.
Yeah, definitely. This is the aim for future.
All right, great. There are a few more questions, but I want to go through the audience questions first because I wrote down a few for myself. We got Database Bob Larame.
Yeah.
We know, some of us know Database Bob.
Yeah.
Literacy includes construction, creation, and interpretation. It's a little discussion that we've been having about what is literacy. And perhaps you can join the discussion. And particularly, we're talking about, does it include programming? Does it include interacting when we talk about visualization literacy?
Sorry, can I get the question again? Because I couldn't hear properly.
I'm sorry, I will repeat that. So on the YouTube channel, we've been having a little discussion about how do we define visualization literacy, and should we include programming in that definition?
Actually, the definition of visualization literacy is ability to interpret, understand, and construct the visualization itself, right? So basically, our software includes construction and also understanding of the visualization, especially the tree map in this case. So yeah, we can say that.
And the follow-up question, of course, is, did you address the construction and the interaction? Because when you interact with the tree map, you change it significantly. You change the way that it looks, and you change what you can read from it. I know from the video that you showed, you did measure interacting with it. For example, zooming into lower levels in the tree. But also, did you test in any way the construction of a tree map?
Not in the evaluation, in the classroom-based evaluation, but earlier we kind of tested our students with the data visualization assignment. So we specifically asked them to create tree maps in the classroom. So, and then we prepare a bunch of questions to check their tree maps and whether they understand or they could construct the tree map properly. So this is our evaluation for the tree map construction.
Exactly. And which brings me to my next question, which is almost a follow-up. Can you talk a little bit about your questions? Because that matters a lot. I have done evaluations with tree maps, and I ask simple questions. For example, how many branches are at a particular node? Or I ask questions, very specific questions about the value, the numeric value of an area within a branch, for example. So I ask different types of questions, and I give multiple choice options. And then, of course, I have to design it in such a way that they are sort of occluders, confounders, distractors, so that within the multiple choices, there are possible answers, but they really need to know their stuff to get the right answer. So can you talk a little bit about those questions? What do they look like?
We basically have two tests, pre and post tests. So we created the pre-test to kind of evaluate their tree map literacy level previously. So this test is pretty much similar with the post-test questionnaire. So we provided 30 questions, and we provided a tree map, different tree map designs with varying level, data with varying difficulty level. And then we also provided some multiple choices as an answer to the question. So, yeah, this is the answer.
But those, I'm a little bit more curious. Is there, for example, are you asking for a numeric value, like a specific, like a 17, let's say? Exactly.
Yeah, some of the questions also ask some specific numbers in the leaf node or internal node. Yeah. And plus, we also ask questions about the software itself. So basically, we have two groups, slides and software session. For the to the students who took who participated in the software session, we ask questions about the software. So they basically could discover the data and use the tool to find the specific number shown on the tree map application.
And we have a question from Jonathan Roberts. The question is, there are different ways to slice and dice tree maps and render them. For example, cushion tree maps. He's saying, you may have said this and I missed it, but did you look at these different methods and ways of doing or operating tree maps?
Yeah, actually, we analyzed different tree map layout algorithms, but we decided that the slice and dice algorithm is the most suitable layout algorithm to teach tree map literacy. initially.
Good. I have one more question, and then I'll leave it open for a couple of minutes for the audience to ask more questions. Are your tools available for others to use?
Actually, this tool is developed for using in the classroom environment for instructor and students. However, we can find a solution for that. So we have a video tutorial that shows all the features of the tree map pedagogical application. So I think we can provide this video tutorial to the students or instructor if they want to use it for learning tree maps.
Database Bob is saying there is a demo online.
Yes.
So perhaps we can either on your paper or as a comment here in the YouTube channel, we can have the link to that tool.
Yeah, that would be great.
All right, we have 4 minutes, and I think we have covered most of the questions. We have a lot of applauses. I don't know if you're also checking the YouTube chat, so people are commending you on your great work.
Thank you.
Okay, so let's give people a few seconds to think of a final question, and then we can move on to the panel. Thank you, Elif.
Thank you.
So, if there are no more questions, then what we can do is move on to the panel on visualization for data scientists. How specific is it? And for this, I will be sharing my screen. I am multitasking, so if I make a mistake, somebody needs to say, call me on it very quickly so that I don't continue talking. All right, so there's a lot going on here. So the first thing is to share my screen. So I will do that. And I need to share the right screen, the one that has the camera, so that I'm looking at the camera. And then, so basically I'm thinking aloud so that I don't make any mistakes. And then, as you are seeing my screen, I have split it into a number of things. And I need to have the cameras for all my panelists ready here on the right. And I need to have the slides. I need to get the slides ready. It almost looks like I'm ready to start talking. I want to change this view here. Perfect. There we go. Okay. It is almost 4 o'clock, and I will go ahead and get started. Welcome to the panel on visualization for data science. We're asking the question, how specific is it? My name is Mario Romero. I'm the chair of this session. I'll also be the moderator, and I'll start by introducing all of the organizers and panelists. Daniela Olke, she develops and conducts data analysis education programs at Siemens. Her work focuses on interpretable machine learning and visual analytics. She received her PhD on visual document analysis from the University of Constance. Ming Chen developed his academic career in Swansea. He is now a professor of scientific visualization at the University of Oxford. His work focuses on the theory of visualization, video visualization, visual analytics, perception, and cognition. Polo Chow is at my alma mater, where I did my PhD, Georgia Tech. He's an associate professor there at the College of Computing. He co-directs the master's program on analytics, and his work focuses on machine learning and visualization for interpretable and secure AI. Eitan Adar is joining us from the University of Michigan, where he is an associate professor of information and computer science. His work focuses on HCI and very large-scale data mining, which also includes methods in teaching information visualization. Adam Peder, he is an assistant research professor at Carnegie Mellon University, CMU. His work focuses on human-centered data science research and education. He's also working on interactive and visual data science, interpretable machine learning, and data-driven healthcare. Beatriz Sousa Santos, who is a co-organizer of this panel, and by the way, Adam is also a co-organizer. Beatriz is an associate professor at Universidade de Aveiro. Her work focuses on data and information visualization in virtual and augmented reality, computer graphics, and visualization education. I am from KTH, the Royal Institute of Technology in Stockholm, and I'm an associate professor in graphics and visualization there. Recently, I've been focusing on virtual and augmented reality and how to do this visualization and graphics in this media. I also do some research in pedagogical methods in learning and computer graphics and visualization. I've done panels on visualization literacy as well, and today I'm moderating. With that, I give the floor to Beatriz.
So, hello everyone. First, I would like to thank the panelists for having accepted our invitation. You are all experienced researchers in the field and also educators, so I'm sure that we can learn a lot from you. And thank you, Mario, for coordinating and moderating this session, which are not easy tasks these days. As you know, data science has been widely used to support activities in diverse domains. Data scientist is currently a position much in demand in the job market. This creates vast research opportunities and the need to better understand how to prepare people to become professionals and researchers able to keep working in a very difficult to anticipate future. It is reasonable to expect that the market demand will continue and that visualization research will keep producing results with interesting industry applications. All this suggests a need to adapt and update visualization courses to prepare these people. There are many visualization courses. Some recommendations also. However, they are not very specific to data science programs. So I suppose many of us now have these new audiences, different from the computer science students we are used to teach, and would appreciate some help on the best way to adapt. So that was the main motivation to propose this panel. Okay, so please, can you show the next slide?
We are on slide number 10. It says many data and information visualization courses. Do you want the next slide, number 11?
Yes, please. So in order to get some insight on the current offer, we analyzed 47 MSc programs in the field of data science, which are lectured in English worldwide. We also analyzed surveys about visualization for data science to companies and to data science programs. And it was interesting to notice that most participants of the Visualization Society survey were self-taught about visualization. Then we looked for information concerning existing visualization courses in data science programs, and we identified a need to discuss some issues. So that is why we invited our 4 panelists who have all been actively involved in visualization education for data scientists. So, and without further ado, here is our first panelist, Daniela Olke. Thank you very much for participating.
So now it is Daniela's turn, and the rest of us can mute our microphones so that she can continue. Daniela, I think you need to unmute your microphone.
Okay. Now
I can hear you. All right, good.
Great. So hello also from my side. Could you please directly go to the next slide? Okay, so what do? I'm from Siemens and I'm teaching there 2 basic courses for data analysis and artificial intelligence. One is mainly about machine learning, artificial intelligence, 5-day course, so professional education course, and the other one is visual analytics, which is 3 days. Next slide, please. Yes. So whom do I teach? It's actually a quite diverse audience. So as I said, it's all professionals. If you go on, please. You see that we have, many engineers are in there, then also computer scientists, mathematicians, sales staff, project managers, business administrators, and so on. Everything that you can think of, every role that basically tests data. And what is, like, for me, a distinguishing factor to classes that you may have in university is that our participants usually have quite a clear goal that they want to achieve with the training. So, for example, they may say that they need the training to analyze the data of turbines, or they know that they have to understand data analytics and artificial intelligence better to manage their projects or to talk to customers. Or maybe they have to report some numbers and want to become more efficient in that. Next slide, please. And I was thinking of if I maybe have a couple of things that might surprise you. I'm not sure if it's really surprising you, but it's maybe a little bit different again from other classes. So the first one is that we hardly don't teach sophisticated visualizations as they are, for example, presented at Eurovis this week. Second thing is that we do not use D3 in our trainings, although this is, of course, very good language, a very good library for producing visualizations. Our participants teach as well in the training, at least partly. And last but not least, an important issue that is often overseen is that often the visualization itself is not the major challenge of the participants. I don't want to go into detail here. If anything is arousing your, making you curious, then just feel free to ask a question. We can discuss it later in the panel.
So now it is the turn of Min to give his opening statement.
Okay, and hope you can hear me. And my name is Ming Chen, and thank to the organizer for inviting me, and thank to Maria for the coordination. Next slide, please. So in terms of specific, I'm going to talk about briefly about the course I just taught in this month. And this is a MSc level course for on the topic of visualization. It has only 4 lectures, 4 hours. But in addition, it does have 4 hours tutorials to support the lectures in the form of discussion. Because of lockdown, we have a slide and a video for the lectures, and then we have a Zoom for the tutorials. And because of lockdown, it's quite daunting for everyone. And so I designed 4 exercises completely on the topic of COVID-19. And there's also an assessment for half of the students. And there's 2 MSc degree schemes involving that. One is the MSc Social Science of the Internet, and the MSc Social Data Science. And if anyone wants to see the slides of the course, the lectures, including the data sets for the exercise, and you can go onto that particular web page. Next, please. And so I guess most people would be interested in how the 4 exercises will be. And the 4 exercises was designed particularly for the social scientists. And the course contained roughly about 2/3 of students coming from social science, the arts, humanity background, and then the 1/3 from mathematics and engineering, computer science, and all other scientific discipline. They roughly have about 1/3 people who had the experience of programming using R, using various of Python type of environments. And so far I'm aware that one student raised his or her hands and indicating had the experience or have a D3 experience. So the first exercise I designed asked people to go have a look at a number of visualization online about the COVID-19 data. Then I asked people to provide their critique. And the focus, I wanted the students to fully aware there's a difference between visualization, creative visualization for the general public and the creative visualization for themselves as a data scientist. And that difference quite often get confused by people working in the data or in the academic area environment, because people have both a role to disseminate information as well as to analyze the information received. Second exercise is I give a student a synthetic multivariate data set and for the COVID-19 scenario, and I create a land of regions with squares and with attached various of the populations and the transports and other information involving that. And I really encourage the student to use parallel coordinate plots to analyze the potential correlation involving that. The third exercise is I'm giving a design exercise. Although the social science students are not required to developing software, but we kind of encourage them at least to be able to involve in designing the software, specify the requirements, and see what could potentially be useful to them. The last exercise, exercise 4, is, of course, a lot of social scientists, data scientists are involved in doing modeling. So I'm taking the modeling as a problem and ask people to consider a visual analytics workflow, working on that. So I'm not going to detail, you can look at the slides and see all the specification of these 4 exercises. Next slide quickly. And so I'll just quickly show you the data sets are created for a land of squares. It has many variables, which is in the form of a typical spreadsheet. And they have a temporal data involving that. So they have, of course, the possible connectivity relation, and so on. Naturally, we have the COVID, the confirmed cases, and the case of fatalities. And I encourage people to use a variety of visualization thinking, but the main thing I want everyone to do, which I believe every single data scientist should learn how to use parallel coordinates. And so that was my kind of forced introduction of these techniques to them. Next slide, please. Next slide. Yeah. So, and for the PPE and the exercise, of course, many countries encounter the difficulty with PPE and logistics. So I made up a sort of a Windows 95 style and the PPE software and asked the student to improve it. And that was really just exercise, ask them to use different visualization to improve that. Again, the detail is that. Next slide, please. So in general, my teaching style tend to give a fair amount of information and encourage the student to learn themselves, and if they become interested in. And I also like to encourage the student to question the common wisdom. So here's a list of common wisdom. I get the student to question them, see whether they are always correct. And if you are interested in, some of them are already being discussed extensively in the VizGuide webpage, and I encourage everyone to participate VizGuide if they can. Thank you.
Thank you so much. Now we go to Polo.
Yes. So at Georgia Tech, I teach a class called Data and Visual Analytics. Next slide, please. And it's very related to what I do for research. So at Georgia Tech, my research lab is called the Pool of Data Science, like you name things after myself. And what we work on is to develop scalable, interactive, interpretable tools for understanding large amount of data and also complex machine learning models and so on. Next slide, please. And the data and visual analytics class at Georgia Tech, you can think of it as like an introductory data science class, mainly designed for master's students, but we also have a PhD student and undergraduate students. It's quite large. The reason is that now it's a required class for our Masters of Science in Analytics program. We started the program in about 2014 and now extended to online following the model of our successful OMS program. OMS stands for Online Master of Science. So it started originally in computer science and now extended to analytics. So now this class is required for both on-campus and online program. And because of demand, go back please, sorry. Because of demand and offer every semester, and the total number of students every semester can be pretty high. So for example, in the past 3 semesters, so it's roughly about 1,000 students. Yeah, next slide, please. Thank you. Yes, and the course schedule is based on what I call the analytics building block. So you can think of it as covering data analysis and visualization all the way from data collection and then to cleaning, integrating multiple data sets, and then do data analysis, visualization, and then how to present the result and convince people to adapt your result, and then do dissemination. And a goal there is to help students learn about how to develop techniques that would complement each other. And main focus is on how to work with real data and real problem and then gain practical know-how, which I think will be really helpful for their jobs and research. So the key focus here is on the breadth. So we cover a lot of things and students need to learn very quickly. Next slide, please. And in terms of learning activities, we don't have exam, so students need to like it a lot. I personally like it a lot when I learn as a student. There are 4 major homework assignments, and they focus on, for example, first one is on end-to-end analysis, how to do data collection and do some cleaning, and all the way to visualization. And then some homework more specific on the topic, like visualization using D3, creating different charts, critiquing visualization. And there's also one big assignment on the big data technologies like Spark and AWS and so on. There's also a main component on doing this group project, so project-based learning, where a student would work in teams of 4 to 6 students and work on a project for about half of the semester. Next slide, please. And for the group project, they can pretty much do anything they want as long as the topic meets 3 core requirements. One is that they need to work on large real data set, cannot be toy data, very nice data. They need to be messy and large. And on top of that, they need to develop the non-trivial analysis or computation. So it cannot be just computing the mean or median. They need to actually think about, okay, so how do I solve a problem using the best way possible? And also have the interactive front end. So that's the user part. So how to interact with the user, get the feedback, and then hopefully improve on the results based on incorporating that. So we have quite a few deliverables over the course of half a semester. Starting with proposal, they do presentation, write a document proposal, and then we have a progress checkpoint, a progress report for checkpoint, and then finally they do a longer write-up and a poster presentation. I'll end here. Thank you.
Thank you so much. It is now Eitan's turn.
Hi, it's a pleasure to be here, and I'm delighted to be part of this panel. So thanks for inviting me and organizing it. I'll talk briefly about a couple of classes that I'm teaching. So I have 2. One is a residential class. It's called SI 649. It's taught mostly in the School of Information, but has a computer science cross-listing. It is a graduate class with 60 to 80 students per semester. We teach it twice, and it's about 3 hours of contact a week, about an hour and a half where it's a lecture and an hour and a half of a studio section where we do a couple of different things, which I'll talk about in a second. It's mostly School of Information students, so people who are doing HCI or information analysis, but really it's kind of the only InfoVis class across campus. So while we have things like visual exploratory data analysis, which is more statistics focused, if you want to do information visualization, this is largely the only class. So it's it's recommended as an elective across lots and lots of different programs, including statistics and computer science. The other thing that I'm teaching now is a online class, which is part of our online Masters of Applied Data Science MADS curriculum. What we did there is we divided our classes into 4-week chunks, and so there's a lot of them, but for information visualization specifically, we have 4-week chunks, 2 on intro information visualization, advanced information visualization, communication using visualization, and then uncertainty in visualization. I'm teaching a couple of these. Right now it's about 80 students per semester, but it's intended to grow. This is our first year running this program. So these are graduate students learning remotely. And our goal is about 250 students. Okay, so I want to talk a little bit about the residential program, which I think is kind of the more interesting one, just because I've had a longer time to develop it. It's a flipped classroom, first by choice, now a little bit by necessity. There are video lectures that the students watch about an hour to an hour and a half with a high stakes quiz that's really actually quite easy. So every time they come back to class, so once a week, they have a very high stakes quiz, meaning it's 25% of their grade. So we actually ensure that they're watching the videos. Lectures have now changed into this active learning environment. So we split up students randomly into groups of 5 to 6 students. And what I'll do is based on whatever the topic is of the week, I'll present some examples or walk through a problem, and then I'll have the students work on it in their group, and then we'll come back together and have a discussion. The lab sections, this is the other hour and a half that students are in class. The first few weeks of the semester, and our semesters are about 15 weeks, the first 5 weeks they're learning some kind of programming or tool. So we've oriented around Tableau for 1 week and Vega Lite and Altair for 4 weeks. We used to do D3, and while students are allowed to still continue to develop their projects in it, we don't teach it anymore, and I'm happy to discuss that. And for the other 10 weeks, the lab sections are something called visit cards, which is a workshop format that I developed. So if we go to the next slide, I can show you a little bit about this. So visit cards is an idea, and we presented this at a paper in Viz, IEEE Viz in 2016, I think. So if you're interested, you can go to the website or read the paper. It's a structured workshop format where basically we give them a problem every week related to whatever the topic is. So if the topic is something like hierarchical visualization, I'll tell the students who are working in a group to visualize a tennis match. So they have 80 minutes where there is switching that's very structured and guided between individuals drawing as many different sketches as they can and coming together as a group and building their visualization. So it's very guided. They have to figure out what the domain tasks are and so on. At the end, they produce one visualization that's sort of the representation of their group on a poster. So this is all hand sketched. What they do with that, and if we go to the next slide, is I will give them then a actual paper to read that is the quote-unquote professional solution, where they have not been exposed to it before. So they have not seen the professional solution before their design activity, and that's on purpose. They will have to read the professional solution and then create a critique or self-critique presentation contrasting their solution to the professional one. So it encourages sort of thinking about why they made certain choices and why the choices were good and bad. This has led people to sort of think through the trade-offs one has to make in designing visualization. So instead of deciding why the professional solution stinks, which is what they default to without that exercise, they have to think it through. So I'm happy to talk about that. I'm also happy to talk about my somewhat strong opinions on education. So I've written various blog posts on this. Some of you may have seen these. I've done things like banning the word exploration in my InfoViz class, and I'm happy to talk about why. I also believe that you should be quite good at using command lines. So yeah, that's it for me. I'm happy to talk about any of these. And thank you.
Thank you so much. This is my favorite slide right here. And with that, I thank everybody. And now we can go to a view that has all of our faces. And we can also go to the YouTube channel. And now we can, I guess we can all unmute ourselves as well. So I want to go to the YouTube channel to see if there are any comments. Okay. Here we go. I found it. All right. I don't see any comments right now on the YouTube chat. I'm also going to check the chat here on okay, good. So in that case, the first thing I like to do is invite the audience to write their comments and participate with the panel. I want to start with a question that is close to my heart. What's up with D3? So 2 of the panelists said we don't use D3. So that was Daniela and Nathan, and everyone else can join as well. So let's start there.
Sure, Daniela, do you want to go first?
Okay, so in our case, it's pretty simple. It's because of our heterogeneous audience or participants that we have, because we cannot expect that all of them are able to program JavaScript. Actually, we even cannot expect that everyone is able to program, and it's not possible just to start teaching them programming as well, in addition to visual analytics, in just a couple of days.
So for us, it's related. We do have a broad set of programming skills, but we found that the learning curve for D3 was quite high. And so students were able to create sort of simple things at the end, but the reality was that other tools would have allowed them to create and iterate over the simple things much faster. So there are students who pick D3 for their final projects. That's totally an option. We give them resources on how to learn it. And so some students who are quite strong programmers will opt to do it, and they'll create sort of new visualization techniques, new interaction techniques. And so D3 for them is great. But for most students, we found that the kinds of visualizations that they were producing were best served through other tools, where they could rapidly combine sort of existing chart types and just modify them a little bit, add new kinds of interactions. And so we thought we would give them the tools that they would need to iterate quickly and produce lots of different options. And we thought that was at the time more important. So there are 2 projects in our class. One is a individual project on communicative visualization, where they build an explorable explanation, and another which is a larger group project. And so we often see in the larger group project some students opting for D3.
I really like this answer. First, because I was a little concerned that we have been left behind by better tools. And I know that there are newer tools, but D3 is still very powerful. And it also addresses the issue that the audience in data science is more diverse. So you need to adapt to that. You can't expect everybody to have the programming background that just the computer science audience would have. Which I think brings me to the next question that I want to throw at the panel, and let you can just raise your hand or start talking. Either one is fine. I want to pinpoint, if possible, a bullet list of issues that need to be addressed when learning visualization for data scientists in particular. We've addressed one. You cannot rely on strong programming skills, for example. You need to cater to a more diverse audience. So that's one bullet point. Can we come up with more that specifically tailors education of visualization to data science? And anybody want to go first? I'm looking at all your videos. Give me some.
I can go. Yeah.
Okay, Polo.
That is Polo. Yeah, I think one thing about data science is to help students develop the thinking, and data science often is about problem solving. I think probably the same for many disciplines too, and developing the mindset that visualization is part of the ingredients needed to help solve the problem. rather than say, oh, so I make things pretty. I think that's still true. Like, I think a lot of times, like, before students take any visualization class, often when they come in, they're like, oh, why do I need to learn all these? I have machine learning, I have algorithm, I come in, why do I need to do data cleaning? How is visualization helpful for data cleaning? I think developing that mindset and showing concrete examples about how visualization is not about just making things pretty. Aesthetics is important, but making that an important part of the solution. I think that the mindset, it certainly needs some help. It's not like just, okay, one lecture or one video and then everyone gets it. It usually is you tell them first and then they do some exercise and then tell them again, or like ask them to tell us. And then so that development, I think that would be one important thing.
Would anybody like to comment on that? Min.
And I agree with Paul completely. And I think part of that, and there's a fair amount of misunderstanding in the among data scientists about what visualization is for. And there's a very large proportion of data scientists would consider visualization is just the end products of all the process, data mining, machine learning, and so on. And it's how to change this mindset to consider the visualization is the integral part of data mining, and including machine learning and all this part of the process. In fact, the most important thing is observation, and the initial data coming in, how can you quickly observe the data? And quite often, because the data scientists don't have the capability to observe data quickly, they don't have really effective visualization. They have basic things, bar chart, time series, and so on. Scatter plot, they feel the visualization doesn't really help them, so they end up with give up visualization in the early stage of their work. But that actually is the most important part. If you ask any physical scientists, whether it's physicists, whether it's biologists, whether it's chemistry, and observation is the first thing. You collect the data, you observe data. And the second part of the data scientist challenge is a lot of data scientists where their main purpose of their work is to use machine learning algorithm or using data mining algorithm is to say, you don't need to use visualization, you don't need to see the data anymore. My algorithm is going to tell you what it is. And I mean, in some way, there's nothing wrong. They want automation and so on, but there's a fundamental misleading thinking is they also, by saying so much about it, they also mislead themselves to thinking they don't need to see the data either, which is really a dangerous part of the data science. And so if you're looking all the data science definition, they tend to define data science as machine learning plus data mining, but the visualization is like a kind of a sideline products if it may be useful. So we have to change it as a community to really say why visualization is useful, and so part of that is our own problem, because we create a lot of the wisdom. We identify a lot of wisdom. Fundamentally, they are damaging visualization in the long run. And
Min, I was thinking a lot about Daniela and sort of her focus on machine learning. And I don't know if that's what you have in mind, but you were raising your hand. Daniela.
I wanted to say that so first of all, I agree with what Min and Polo said, but I want to add something, because I think visualization can also be extremely useful for data scientists in the process of finding out what exactly has to be done, what the machine learning task is that has to be solved, because that often involves talking to domain experts. And that's really, I usually in my class, I tell them that this is like a gap that you have to cross. Okay, it's not, they are not going to serve you the data analysis task on a silver platter, and they don't know exactly what you can do and is in the data, but on the other hand, you also can't specify the question, the data analysis question, without them. So in my experience, data visualization is a great means also for bridging that gap, helping you to talk to people just by showing them first effects and getting into a discussion with them.
Absolutely. Thank you. We have our first question from the audience, and it is Martin Skrotsky. Data is often collected in specific domains where the data scientists lack the specific domain knowledge, but the domain experts lack the knowledge of data analysis. The question is, how does visualization help here?
That was exactly what I was trying to say, by the way.
Yeah, exactly. Exactly.
Helping to bridge the gap, yeah.
Does anybody else want to comment on that?
A quick comment. So exactly what everyone said, and that observation experience from some research project where actually the project initially doesn't have any need, or visualization is not written as part of the deliverable. But then interestingly, usually when we do the development, even it's machine learning, and then we start to say, oh, we want to look at what's really happening, what have we learned? And then the visualization, the output eventually actually helped the project a lot, because once you put in on the same screen, everyone had the same space, looking at it, same language, and that really helped the project a lot. So that's just interesting observation that sometimes visualization is not the initial plan, and I'm perfectly happy with that. And I wouldn't say, oh, well, you need to visualize it. Usually it's through the process and everyone starts to see the value. Yeah.
Yeah, it's a very good question, Martin. So I think the short answer is collaboration, and a part of our education in terms of giving visualization courses is to teach or to make people who may not be like social data scientists or physical data scientists to be aware they can call for help when they need, be aware of what can be done and what needs to be done. And the data scientists, some data scientists are wonderful, and I worked with a US team in Chicago a few years ago, and they've been using machine learning for doing some text analysis for 5 years, but the results wasn't great. Then I said, could you give me some examples of machine learning kind of failed? Oh, they say, how many you want? Within a day, they pulled out 50 examples and they emailed me and email us. So we can start to see why, from visualization point of view, why visualization can help the sort of the false positive, false negative results, and to help them out in that sense. And but sometimes they also we all must encounter the data scientists would say, oh, my machine learning algorithm is always good, and it can't be anything better, and my model is the best model in the world. How dare you challenge it to say you're going to try to improve it? How much you know? And so it is a kind of education to really let people aware how powerful visualization is a tool to enable people.
Thank you. Beatriz and Adam have been very quiet, and this is the panel they organized. So please take this opportunity to share what's on your mind.
Yeah, I'd like to follow up on this because, again, pretty much all the panelists agree that there is this misconception of when data visualization is useful. But when Beatrice and I were kind of analyzing data science programs throughout the world, it's pretty much a rarity for a Viz course to be a requirement. Sometimes it's an elective, oftentimes it's not often offered at all. And so I guess the question is this a problem? And how do we fix it if we feel that, people don't really understand the true benefits of when data viz is appropriate?
So I think that's an interesting question. For us, we do require it, but we have actually multiple classes where visualization is embedded as part of them. So we have what we call an exploratory data analysis class, which I don't love the name, but that's what it's called, where that is for people who are specifically applying visualizations in the process of doing some kind of statistical analysis. So we teach them how to do the proper kinds of histograms, QQ plots, how to read them, what they mean. And so that is tools in the service of that statistical progression that a data scientist might have. So they have a hypothesis they need to, or need a decision point about which algorithm to use. And so that that kind of class is like, here's a very traditional set of plots that will serve your needs. But the other thing, I guess, related to this broader question and maybe the specific one is we try to emphasize this layering. We use Tamar Munzner and Mario Meyer's model that there's domain tasks, abstract tasks, algorithm, and so on. So we emphasize this, and this runs throughout all our courses, at least the ones I teach, where like you basically have to isolate what the domain task is and then find the abstract representation. So the domain task might be whatever the biologist is doing in their questions. The abstract task might be, oh, they're trying to do a correlation between two variables over time. And then they have techniques that they've learned about that sort of solve this. But by forcing them to find like what the domain tasks are, which of the techniques they know about, what the abstract representation is, and so on, they're able to build a collection of techniques and algorithms and methods that then they can apply in different scenarios. So that's a way that we try to emphasize that you need to do this process of separating out these different things, because for data scientists, we're trying to train them to work broadly, right? They're not often just being trained for doing a very specific thing. Like some of them will want to be in learning analytics, some of them will want to do game analytics, some of them will want to do whatever, but it's our job to give them a set of tools, I think, that will help them do work across these different spaces. So that creates interesting challenges. I'm curious if other people have encountered that, but there's always a little bit of resistance in our students, like, oh, I only want health data sets, and it's like, no, I'm sorry, like we have to do across all these different areas.
I'm going to go back to the audience. Gita Domik is saying, hi, Beatriz. And she's interested in sort of the differences between pure data visualization and what we call visualization in data science. She's given an example here. For example, data visualization emphasizes spatial data stronger. And in data science, we emphasize multivariate, time-varying graphs more. So this is one example of a difference between pure data visualization and data visualization for data science. Can you comment on that and perhaps expand it? Min.
I guess I'm the oldest chap there. So this is there's no such thing as a pure data visualization, and there's a historical visualization was developed for scientific applications in the 1990s, and then the InfoViz, which really emphasized our multivariate data set, graph, network, text, and that was largely become popular in around the 2000s-ish. And nowadays, you can see all this different type of data types, and they all mix together in various applications. And most importantly, around the early, about 2004, 2005-ish, the new area introduced to looking into the interaction between the algorithm and all the visualization. Essentially, look at between the human-centric process, such as visualization and interaction, and the automated process, such as statistics and algorithms. So that is the visual analytics part. Good things is next year, 2001, and the three major conferences, the SciViz, InfoViz, and the VAST, is going to be merged properly, and there will become 6 areas, and we'll concentrate on the theories, application, and visual representation, device systems, algorithms, and visual analytics. The name is not exactly the same, but that's roughly the 6 topics.
Thank you. We have one more question. This is from Han Ki. And it says, data scientists are working under time pressure. Standard visualizations are powerful and easy to make. By this, I think he or she means, it's simple. Like a bar graph, it's simple. A scatter plot is simple. Why go to the trouble of doing parallel coordinates, for example. So they are satisfied with these simple visualizations. What are some research opportunities do the panelists see here? What are some of the research opportunities that the panel see here? Would anybody like to make a point there? And I think some of your opening statements had these points. Min, you raised your hand, but you spoke last. Will anybody else like to cut in?
I'll let Daniela.
And Daniela, did you also raise your hand?
Yeah. Yes. Then I go first, and you can go second. So first of all, I can agree with that statement. In many cases, the standard visualizations are enough, especially if you combine them in a way that there's a brushing and linking or interaction possible. And that's basically also what we teach them to do first. But my experience is also that people are also quite open for what we would say are more sophisticated visualizations. The problem here is indeed usually, as was said, that they are under time pressure or they cannot spend a lot of time in programming things. So if you offer them a possibility to easily use these more sophisticated visualizations, they are probably likely to use them. And you mentioned parallel coordinates. For example, parallel coordinates are available. They are easy to produce and they are used. People also like these pixel-based visualizations a lot. This is something that you can almost do in Tableau yourself, and they are really, they are used if they can be used easily. So that's maybe something. It's not a research challenge or a research question, but something that I can say to the research community. So the easier you make it to use your stuff, the more likely it is that it's really used in practice.
Min.
So it really depends on the needs of the user, and some users use visualization occasionally, and there are many users involving big data. They use visualization really intensively. So for example, one project I worked on, we have 6 analysts that use data visualization 8 hours a day, 5 days a week. It's non-stop, and for people like that, if you can use visualization to improve their performance, as Daniel said, on speed, on identify the problem, identify the patterns, and you only need to improve them a little bit better, and with a specialized visualization, and it will be much easier. Another thing is when a user have a lot of work to do, they are more willing to learn specialized visualization. So that is also difference. So one typical visualization is like glyph-based visualization is very special. Generally, it's not cost-effective to develop a glyph-based visualization because the cost of developing, cost of learning is very expensive. But when people are doing it every day, every week, then it suddenly becomes effective. And so there's a cost-benefit analysis related to the visualization itself. Yeah.
Thank you. Adam, you want to add?
Yeah, just a related question. So this week we're all at Euroviz, and there's lots of these exciting new techniques being presented. So I guess the question is how applicable is it to show these in these data science courses? Is it better to focus on these traditional statistical plots because they can do them in a cost-effective manner, or do you think there is still value to kind of exposing the students to these latest and greatest techniques?
My belief is yes, that we should expose them. I think it's my job as in teaching these classes is to expose students to a broad set of tools and let them build a toolbox that they can apply. Now, most of the time they'll reach for a scatter plot, just like you would reach for a screwdriver because it solves most of the things, or a hammer, I don't know, whatever it is. But right, there's a set of things that are very common in your day-to-day life and you will want them, but I also want you to understand that there is this rare tool that occasionally you will need, or if that's your entire job, like you're a plumber, right? Here's a set of tools that you will need in that role. Maybe people don't like this metaphor much, but anyway, I think it's our job to give people an exposure to different things because we don't know what they'll need to use. We should teach them the things that they'll use most often and be very good at using them. So scatter plots, histograms, whatever, you're going to use that a zillion times a day. And so I'm going to teach you how to make those and how to understand them. but I'll also expose you to these research projects. And in talking about that, we try to pull out like broader lessons as well as specific things. So if the tool was only built or presented as something that was only built for biologists, we can still look at the things it tries to solve and pull out the more abstract lessons, like, oh, this is a great technique for looking at time series data, and you should put that in your toolbox for later if you need it. I have birds going crazy outside my window.
There's something you mentioned, and it caught my attention. You want the students to use the basic techniques, but use them correctly. And you will be surprised. Everybody is sort of tired of seeing graphs that don't have the right labels, don't have the right legends, don't have the right colors or size of the text. Simple details like that make or break the graph. So I think it is an issue to teach people to use the tools correctly. We have another question from Jonathan Roberts. With literacy, one good teaching method is to get students to reflect, realize what they have done and applied. In your VIS courses, do you, and if so, how do you get students to reflect? Polo.
I'll comment on this. Actually related to what everyone was saying too. So showing before and after is a very powerful way to help train them to do reflection. Usually we'll start with doing some example in class. So for example, I had one class is with, we call the title was like do's and don'ts in visualization. So show them first, okay, so this is what you see, anything wrong? Or I say, what I actually would change the wording is, what can you improve on? Is it really already very good? Initially, in the beginning of class, usually you say, oh, no, that's fine. That's no problem, right? And then you kind of start to probe, and some students will start to raise their hand, I think this can be better, this can be better. And then this is actually using the kind of problem-driven way to help them to think. And then through the lecturing, show more examples. Okay, so this is original, this is better. Is it better? Why is it better? And then so that's one way, more like passive, if you would. But then in the assignment, we also ask them to do, okay, so here's the beginning. So now think about everything that you learn or have seen. You don't need to come up with a perfect way, but think about what can you make it better. So kind of help them develop that kind of thinking. Sometimes you also need to provide examples too. For example, for when a student are doing research, sometimes I sit with them, maybe spend 1 hour or 2 hours just to say, okay, this is your initial design. So this, I would change it like this because, and so they see both before, after, and then also my rationale, and then they can adopt that thing. So that seems to be pretty effective, at least for me. Yeah.
Thank you. Eitan, I'm going to you because you said something that I found very interesting. You have them think about a design problem, a challenge, before you show them the literature. And you try to make sure that they haven't seen the literature. Although, dedicated students may actually have done the literature review for the design challenge. So this is a follow-up, because when they compare their project to their to what the pros are doing, they're doing a self-criticism, they're doing a reflection. So first, how do you ensure they haven't seen the paper, because they could go out there and use Google Scholar and find it, or something else. And then also this goes back to the question about reflection from Jonathan. So comment a little bit on that.
Sure. Yeah. So they don't actually know what the project will be, like the mini design exercise will be, until they show up to class. So they're pretty rare papers. Like the things that they have to read in advance, I give them enough stuff like learning about tree maps, or learning about like why you structure trees in hierarchical design this way or that way. So they get enough reading anyway. They're not going to go digging for like really obscure applications of these things. And then when they come to the lab session is when I actually give them a sheet that says your design spec for today is this, this, and this. So none of them have thought about it. If they have, it's often in very vague terms, and so they haven't seen many solutions. So the other thing that we emphasize heavily is lots of iteration. So the way that workshop is designed is like you have to spend some number of minutes making as many like crappy design sketches as you can on paper. Then you talk about it in your group. Then you have to go back and make as many new crappy design sketches as you can. And we have them log it. Like they basically put it up into a slide deck at the end, all the different choices and ideas that they've had. So we emphasize this notion of trying lots and lots of different things and comparing and contrasting. Like, given that our design spec was this and we decided on these domain problems to tackle, is this visualization better than this other one? How will this one scale relative to this other one, and so on? So that's the kind of thing we emphasize as a kind of local self-critique. And then globally, for the next session, they have to read the paper or look at the project and compare their final solution and sort of make a clean presentation that they can do in front of class. So there's the mini critiques that happen often, and then the larger critique as well, and we give them feedback too.
You also said that sometimes they say that the professionals are not doing the right thing. Is that really happening?
It used to be that they would just say, oh, the professional is like, they made a mistake, like it's bad. But when they have to do it themselves, like in that exercise, they realize it's a trade-off. So this is like the wicked design aspect of information visualization. They realize that you can't serve all the different visualization tasks you might have. You often have to make decisions about prioritizing this versus that. And they're forced in the way we've structured this to pick a subset of domain tasks. So in the tennis example, right, there's like 50 million things you could visualize about a tennis match, but I tell them you can only pick 5. So you can only pick 5 that you will tackle, and then they realize that their solution is limited because they're not solving all these other things. So it's become less of a criticism of like, oh, these people did something wrong, but these people picked different trade-offs than we did.
We have 4 minutes left, and we have had a panel that agrees for the most part on everything. So it's an interesting panel, but I want to see if I can get some contention going on. What's up with no exploration?
Yeah.
Okay, I get to be the troublemaker. So I've banned the word exploration in my class because I don't believe that data scientists, or pretty much anyone, that the goal for these people is ever exploration, that the goal is always finding. So I prefer a language that's focused on finding. So what is it that you're trying to find in the data? And then they're not allowed, so students are no longer allowed when they're making a project proposal to say, oh, I want to build a tool to explore bird strike data or whatever it is that they found like out in the wild. I force them to say, what is it that people are trying to find in the data, and then are your visualizations supporting that? And so that doesn't allow them to sort of build very open-ended tools that they throw out into the world and say, this is a great solution. They actually have to face the fact that like their tool might not work given the specific data finding needs of the analysts for whom they're building it. So that's a thing that I've decided to do in my class. The students don't love it because it means more work for them. And I've had some resistance to this. Like, some people don't think that this outright ban is a little bit much, like both in the pedagogical InfoVis community and in my students, but I've opted for this. I guess I'm curious if anyone has a negative or positive reaction to this.
Polo, quickly.
Yeah, quickly comment. So and then when the universe showed that title, I thought, ta-ta, so I'm going to get this fire at some part of the panel. And I read the article. Actually, I agree completely. I think this is the context of the class, right? And students don't necessarily know what exploration could help with. And yeah, that happened in my class too. So a lot of team projects. I'm going to build this tool, and I said, okay, why do you build this tool? To visualize these data. I think, okay, so then for what? So I think that the problem there, like, what do you want to discover? Like, what's the goal? And there often is not very clear. So actually, yeah, sorry, that's no fire from me. I completely agree.
So we end up agreeing again. I want to give everybody 15 seconds to close, say goodbye, and then I will close at the end, please. Let's start with the organizers, Adam and Beatriz. Is there anything you'd like to close with? Just a good handshake. Anybody else would like to give it a close, or otherwise I will give it the general close. I think I go. So I would like to first thank the panelists for dedicating their valuable time and effort to doing a great job. I think everybody has done it. And the organizers, of course, who have dedicated the most time. And then the audience, who have been active and asking really good questions. Thank you so much. And finally, I want to thank the organizers and the technical team today. Jonathan is joining us and making sure everything is running. I can see on my left the YouTube video looks great, and he's almost reading our minds. Thank you so much, and enjoy the rest of the conference. Goodbye.
And thank you, Mario, for organizing this.
Thank you.
Monitoring and coordinating.
My pleasure. Thank you.
Bye-bye.